Welcome, respected Animesh Chaturvedi sir, and my dear friends. Today, me and my group mates will be presenting on our minor project topic, which is real time hate speech text analytics for dynamic content moderation in mobile applications. So, we have done this project under the guidance of our mentor, which is Dr. Animesh Chaturvedi. He has been a great mentor for us in providing us invaluable guidance and direction for our project. He has also actively been involved in the project discussions and the brainstorming sessions that we've had in order to decide the direction and the aims of our project. His role as a mentor has empowered team members to excel in their respective roles, fostering a collaborative environment where everyone feels advised, motivated to achieve their best work. In today's world, social media apps like Instagram, Snapchat, Twitter are being used on a large scale, especially by students and children of our age and our age groups. So sometimes you can see that they face problems like the data they consume can be abusive or hateful. We also want to detect these kind of hateful and abusive speeches that are being used on the social media apps. So the main inspiration behind this project is to give early warnings to users that might harm others emotionally by their content. So we made our own application in our project where we have features like uploading of text and memes. We can like, we can share, and we can also comment on these memes. And we are setting priorities of posts with respect to the vulnerabilities that are being detected in the posts by our models, which are machine learning and deep learning models. Also detecting the hateful texts and comments to save user time by highlighting them using our own models. So many a times you can see that in social media apps, influencers post their photos and there are hateful comments on these posts. So using our ML model and deep learning model, which we have applied on the real-time analysis, a user can understand the hateful and the abusive comments directly by using our model, which will highlight all these comments. The classification of hate speech is done on these three labels, which is hate speech, offensive speech, and neither. Also, the process of hate speech detection using machine learning involves training a model on a dataset of labeled examples, where each example is labeled as hate speech or some other class.
Models. Here you can see the contents of our upcoming slides. We directly move on to the upcoming slides. The first one is requirement analysis. In today's world, our youth and teenagers are wasting hours, tens of hours of their time in the social media app that can impact their social, physical, and mental health. So, by seeing abusive or offendful words, to encounter this, we come up with our sentiment analysis model embedded in our app. Now for the dataset description, our dataset is taken from the Kaggle and is free for our experiments. It consists of thousands of tweets categorized as offendful, non-offendful, and neutral. It also consists of 5,000 plus memes, and the text is also extracted from them. Now move on to the data pre-processing step. The first step in our processing pipeline was the noise removal. We clean up the irrelevant symbols and special characters from the text. Then we perform the tokenization, which involved breaking down the text into individual words or token. Another key process was the removal of the stop words. Removing these words helps to reduce the dimensionality of our data. We also employed limmatization, which simplifies the words to the base or to the root form. This reduces the complexity of our data, helps the model to perform better. Now the further steps are handling the URLs and the special words. In dealing with the text, it is important to handle the URL and special character carefully, as they can screw to the analysis if not properly handled. Now moving on to the visual data, the memes, due to the size of the data set and the limited resources, we use the batch processing to load and handle the memes efficiently. Each meme was converted into a NumPy array of pixels, and then we create embedding from each array to train our models.
For hate speech analytics, we use several models like logistic regression, naive classifier, LSTM, random forest, voting classifier, and at last we use digital roberta based uncased model, for which we have got the maximum accuracy. So for digital roberta based uncased model, it has 6 layers, 768 dimensions, 12 head, 82 million parameter. We have encoded the original text and then trained it. For output layer, we have restricted the 3 output layer as per our requirement. Let me show you the code for this. Coded the text and finally converted into the array. Train test split. with Adam Optimizer. We have used sparse categorical cross entropy, and within 5 epochs we got around 90% accuracy with a test loss of 0.31. We did time series analysis too. We analyzed days of the week and its count, and found out that the abusive texts were mostly posted on Thursday, as well as non-abusive text. The count was more than 200 for abusive. We did analysis on hours of the day as to find out at what hour of the day the mostly users were active in posting hateful and non-hateful speech, and found that they were mostly during night time and during lunchtime. For month analysis, we found out that hated comments were mostly during September to December and June to August. These were also same for non-abusive text also. For the dataset, we have 5-year dataset, and in that dataset the count of hateful speech was more than 200, and for non-abusive text this was around close to 120. So this was all about the time series analysis we did.
Let's move on to the memes hate speech model. Here we are using a deep learning model that is consisting of image as well as the text data, and then we are concatenating these two features in order to finally classify it into 5 sentiment labels, which are very negative, negative, neutral, positive, and very positive. These are the 5 sentiments that are having impact on the users, and the model that we've used is VIT SBERT BiLSTM model. And here we can see that the VIT pre-trained model that is being used in our concatenated model is that ImageNet21K, which gives us the image embeddings which are further used for the training. And the text embeddings are gotten by the SBERT and BiLSTM model, where we are able to get the context of the entire statement, and finally these are getting concatenated and classified into the 5 sentiments.
We are discussing the flow diagram for meme classification model. So for meme classification model, we have two parts. One is image processing and second is meme text processing. For image processing, we have to load the data in batches, and we have to use VIT-BERT for image processing. Then embedding and flatten of array of images has been done, and then we are returning the final images array. For text processing, we are use SBERT model for tokenization and encoding, and then conversion of that text to a NumPy and TensorFlow array, and then we are concatenating both the image processing and meme processing model. For testing the hate speech classification, we have used 6 different type of models, that are logistic regression, random forest, LSTM, naive Bayes, and district low database. Among all, we are getting 92% accuracy in district low database and around 80% accuracy in among all the model. For meme classification, we have used 5 different type of classes, and among them we have got approximate 46 to 47% accuracy, which we are trying to improve in coming projects. So here you can see that all the model which we are using, and accuracy, precision, recalls, and F1 score. Among all, least score we are getting for KNN at around 78%, and district low database around 90%. And for meme classification, you can see the accuracy we got around 46%, and all the remaining classes what we have built, I give a precision, recall, F1 score, and support value this. We have built an application where we have integrated machine learning model to a real-time application. This application was made using Flutter and Node.js. Features we have is real-time notification feature, personalized customization, activity feed, search functionality, content moderation, notification counter which will increase on notifying, on comment on someone post, adaptive theme where we can change the theme according to user needs, and also I have hosted that model on AWS. So now I am showing you the real-time demonstration so that you will get a better understanding. I have recorded a video which I am showing you here. So yeah. So once I write a hello here, which is a normal word, and post, so it will process because we are hitting 2 API. First is comment API and second is model API. So it takes some time. When it's get loaded successfully, you can see that you can see that comment has been added successfully, and also the classification is coming as 2, which means this is an normal text. Here on backend also you can see the response is giving me 2, and on model API also here you can see that on comment controller I am adding the text, and then I am passing that text to a model API which I have created here, and this is also running on locally server. Yeah, you can see the head hello API has been hit, and you are getting 2 as an output, and based on that we have given a blue color and neutral text, because this is neither offensive neither hateful, as comment count will also be increases here. Yeah, it's showing 1. Now I'm giving another comment, that is fuck, which is a common word used in this age people. So this will give us 1 as a classification because this is a hateful speech, and also you will see the response is getting 200 because it means that API is working properly, and classification is giving as 1. And in this also you can see that comment has been loaded and is get 2, and once I click on that comment you will see that it's in red color, which means it is a hateful text and it is warning the user. As the time doesn't permit me to show more demonstration, I am giving you the GitHub rep, and I have added a screenshot also so that you can use in your app mobile application and get a real-time experiences of our app. So these all are the features of our app. You can view this.
Now we move on to the cloud services that we have used. The first one was the MongoDB Atlas, which acts as an AAS and PaaS provider. Then for hosting our ML models, we use AWS EC2 instance, and AWS EC2 instance was paid, so we shifted to Render, as Render was free of cost. And for running and training our model, we use Google Colab. For image management and media management, we use Cloudinary. Here you can see the snapshot of our AWS bill. Here in the bill you can see the service provider name, that was Amazon Web Services India Private Limited. The bill was generated till 1st April till 30th of April. The total bill cost us around $4.56. Here you can see the uses of our AWS services. For 1 hour, the AWS cost us around $0.0688, as because we use the Linux T4G.large CPU. Now I will show you the uses of AWS as per our services. In total we have used around 8 services. Here in this graph you can see we have used AWS EC2 instance, S3 bucket, EC2 other, VPC and key management service. In this on the 15th of April we have also used the Cloud Shell. In the 16th of April we have used the same services. Now we change this graph to different form of graph. You can see the graph on 14th and 15th of April the usage was maximum. Now I will show you the graph according to our API operations. In total we have encountered around 53 times of our API. Here you can see for 14th of April the cost was around $1.6. Now I will change the form of the graph. Here you can also see in around 14th and 15th of April the usage was maximum, and it was average costing us around $0.27 per day.
Team consisting of Aryan Kumar, myself, Mayank Kumar Shah and Nikhil Baghel. And I would like to conclude our project with the type of models and the type of technology that we are providing to today's world will thus help us in reducing the hateful and the abusive content that is being consumed by the users and the students of our age, thus having a positive impact on the tech view and as well as the social media view. Thank you friends for visiting our presentation.